Welcome back everyone to Data Science for Everyone. Today we're going to be doing a continuation of our interactive plotting with Plotly Express. Let's get started. So let's get started back with Plotly Express and the Gapminder dataset. So import plotly.express as px. And then we want the Gapminder dataset. I'm going to call it Gapminder. And then we do px.data.gapminder to run that. And then we are going to do a line graph of that same data. So Gapminder. We want X here. We're going to make this a time series. So we want the year. Y is going to be our life expectancy. And then color here, we'll do it by continent. And then we want to create line groupings. So in here will be for each of the countries. So what this will do is that you'll have color coding. So all of the colors, for example, like red will be Asia, blue will be Europe, green will be Africa or something. But then you will each, instead of just having like one chunk or something like that, you'll have a full line. Each line will be represented. And then so on top of that, then we will want to have a hover name. Since we're going with the country for the line group, it's also good to have the country for the hover name as well. And then the line shape that we're going to be using is a spline. And this will actually give us a very smooth curve, which is going to be very useful for us. Otherwise, sometimes it would be maybe very jerky lines or something like that. But when we use the splines, there won't be those harsh ticks moving all over the page. And so let's just run this now. Oops, and I need to actually do a render. I forgot about that. This one we need a render mode here, and this needs, I would usually probably do an SVG. SVG is a very high render mode, so that whenever you export your graphics, it'll be in a very high format. For example, like when you zoom in on a graphic or something like that, if you use SVG, particularly when it's static, it won't lose as much. There won't be a lot of pixelation. So you can see here that we can go on and turn off the continents. So let's keep. Let me actually reset it real quick, and let's turn off everything but maybe Asia. And you can see that everything kind of resizes in here. And again, here you see, for example, Cambodia again. So this is when we had, I believe, Khmer Rouge, those types of things. He had kind of like civil war going on there, and it really dropped down. So again, this is a nice way to see things with a line graph. Now you can also do some more area types. Now I'm highly opposed to using pie charts. Okay, they are very messy, and a lot of people have a tendency to not understand them very well. But we can do something which is called a sunburst, which does have a little bit more variation to it. Okay, so let's do something like, I'm going to call this Gapminder 2007. We'll make this static. And so we'll do our Gapminder data. And then we want to query here. We want our year to equal 2007. And then we'll actually create our sunburst. So px.sunburst. And then here we want our Gapminder 2007. Now the path in here, we're actually going to do two paths, which is going to be kind of nice. So then we'll have this, we'll have like an inner ring and an outer ring. Okay, and so the inner ring in this instance, we would want a continent. All right, and then the outer ring we want to be a country. Okay, and you can do more than this if you want to. Now I would suggest when you do this, okay, do things that are dense inside. So for example, there's only going to be 4 continents in our data set, and then on the outside there's going to be many countries. Okay, so then that's actually what you're going to want on the outside of the outer ring. So if we had maybe states, okay, after that for the countries, or you had other municipalities or whatever else, then it would maybe go out one more ring. So the next part in here, we want values. And so let's do the population. Color, we're going to do this by life expectancy. And we'll give our hover data. Here, let's actually give it, let's use something new. So let's do our ISO. And this needs to actually be in a list, is an ISO alpha. Oops. Path. Why did it not like my path this time? Oh, okay, they may have changed path. So let's take a look here. What are you supposed to be? They changed that? Names. So they changed path to names, I believe. No? All right, let's try that one more time. So you guys get to see some debugging in real time here. Maybe they changed it. Is it parents now? Let's try parents. It's not parents either. Hold on. All right, let me look up some. Okay, so the issue actually comes down to the Plotly version that's going on right here. Okay, so if we want to use this Sunburst, again, this is because Plotly is actually already installed on Colab, but they are currently using Plotly version 4.4.1, and we want actually a newer version of Plotly. And so the newest version of Plotly is, I believe, 4.14. So actually we need to upgrade a lot. So we can then do something like, to fix this error, let me do it up top here. So fix Plotly errors by upgrading Plotly. So here you can use the exclamation point, pip install, and then here we're going to do Plotly and run that. And this should, it says it's already satisfied here, but we should, let me rerun this real quick, and we can force install a newer version. So let's do pip install, and then it is what we want, 4.14.3. This is the current highest version. And this is as of what is today? Today is March what? March 3rd, 2021. And so let me rerun that. And so now you see that it's actually going to be installing this, and then we'll have to rerun each of our pieces, and hopefully we'll check and see if there's anything that breaks any of the code that we've written before. So again, right now it's installed and it's uninstalled. So we need to rerun, and here it's actually telling us to restart our runtime. You know, I don't want to do that right now. I'm just going to run this and double check everything. All right, that worked. Now let's check our Sunburst. And it says it still did not work. Why? Let's check our Plotly version. Okay, so it did not actually install that for us. So let's restart our runtime. And it looks like, all right, now let's give it a try and see. After restarting our runtime. Yeah, there we go. Okay, so to get the Sunburst to work, we need to make sure and rerun all of this, and then also restart the runtime. And again, it does tell me this here. I was just wondering if I could get away with it. properly. So this is the sunburst. So let's kind of talk about this. This inner ring here is from this path argument that was giving us trouble before. The inner is the continent. And so this is it is aggregating the population of the continent for Asia, Europe, and actually there's another one in there. There's Oceania. It's a little bitty tiny. And so that's New Zealand and Australia. So Europe, the Americas, and Africa. Then the nice other thing that we have here is this outer ring, which is the number of which is the countries. Okay, and it has all of this information. So for example, like if you were doing sports or something, maybe this would be all of the leagues here in the center, and then maybe on the outside you do all of the teams. Okay, or maybe you have all of the teams and then all of the players, something like that. Again, all of the players would just be massive. Okay, so I would suggest against that. And then here we have also this. It's nice and color coded based on the life expectancy. This purple is low life expectancy, the yellow is high life expectancy, and everywhere between there. And this is great because you can see, for example, inside of each of these areas. So for example, here is Africa in here, okay? You can see that there's some places that actually have relatively moderate to high life expectancy. I think somewhere in here there's probably Maurice. Somewhere in here is actually pretty decent. Oh, here. Oh. Somewhere Benin. Oh. Mauritania. Okay, so it actually has a moderate as well, and then so Egypt here is actually quite up high. So again, this is nice to be able to compare a lot of your data, and it's a very data dense type of visualization. So, and another one that's on the very same type of idea is using a tree map. And so let's actually give that a try. So we'll use the same data, so you can actually see a bit of a difference in here. So we want the Gapminder 2007. And here we're actually going to do something a little bit different. We want path here is actually going to be a px.const. All right, so it's a constant, and we're going to grab world. Now, if I just run this down here so you guys can see what happens here. Let's do px.constant, and I want world. All right, this is an object. And let me see if this does what I want it to here. No, it won't. Okay, so but it actually keeps a nice object in there. It has built-in information for us. And let's do here, we want, continent, and we also want country. And what this const world is going to do is it's basically we're creating a box, and it's going to have the whole world kind of outside of all of this, outside of the continent and the country. So it'll be very similar to this in shape, and we'll talk about it once I actually put it in there. So our values are going to be the same for population. We want the color here is going to be our life expectancy again. Our hover data is going to be, again, we'll put in the ISO alpha. And let's run this so you guys can see. All right, so now you can see this the const that we created here was world. Okay, it's this big one all over, and it's actually just added everything in for us. Then we have Asia, and notice it actually gives us this nice box around it, and then inside of there it has all of the data itself that you can hover over the top of. Okay, so think about this again as maybe again, we're currently going through the COVID outbreak. So think about this. We could do the world, okay, and maybe the number of infection rates. Then we could break it down by continent. Then we can break it down by country. And then even inside of those, we could even break it down by state as well. And this would make a fantastic interactive map for people to understand what's going on with the pandemic. And you can also put in some of these, similar to how we'd had some other interactive graphics, like having it change over time. I would ask you guys to give that a try if you wanted to. Now, the next thing, I know that these are pretty, but now let's actually get to some more serious stuff. and that is actually doing distributions. So, and again, this is when you talk about data science tools or something, distributions are probably the more useful thing that we look at. So let's do our tips data. And let's go through and do a histogram of our tips here. And we'll do the same thing that we did when we did the Seaborn lectures, and that's total bill. We want y is equal to, y is equal to the tip. We want color, here we'll have it as sex of the waiter or waitress. And our marginals, here we want rug. So then we'll get to see the observations, and we'll do hover data here. And let's actually have it as df dot, oh, not df, we have tips. Tips dot columns. So it'll just be all of them. So now we see here that we have this fantastic two-toned histogram of whether they're male or female, about the total bill, and the amount of the tip. Now we also have a fantastic thing here using the rug plot. We can actually see each of the observations up top. And again, we can always, as usual, we can toggle them off for male and for female. Okay, or we could do this again for smoker, non-smoker. Let's actually do that. So do smoker. Here. So smoking, yes and no, and we can see then, we can look at the distribution as well. So this is a great way to visualize things, particularly when you're wanting to make sure that your data is normal. And again, here, for example, we have this whole area here is our outliers, and so we can actually zoom in on our outliers and take a look at this. I mean, so here we only have one observation here. We have 3 observations here for these really high tip, high bill. And then here we actually, you can see this again as how many observations are actually there. So if you're wanting to get rid of your outliers or something, this is a fantastic way to actually look at that as well, to see what's going on there. The next thing let's do is let's do a box plot. So, and let's do the same, basically the same thing here. Box. We want our tips data. X, let's do this by day. Y is going to be our total bill. Here, our color, we'll put this as our smoker. We'll do it the same as up top. And we want this to be notched. Well, you know what? Let me do it non-notched, and then I'll do it notched. So here is this the normal box plots, okay, that we're accustomed to, but something that gives it a little bit of let's call it flair at least, is we can do notched is equal to true. And this gives it this little bit of an hourglass shape here so that you can really focus in on the median here, and then you can see how it actually goes up from there as well. And then the next one, again, probably one of my favorites, is doing violin plots. So let's do violin plots. Violin, and we'll do tips again. Y is going to be tip. Oops. Let's do X is going to be smoker. Y is going to be the tip. Color here is going to be sex. And you know what? I'm going to, let's do hover data is df.columns. Oh, not df.columns. We want tips.columns. And let me run this. Okay, so now we see here, we have our normal violin plots. These dots signify where we have outliers, similar to what we have with our box plots here, but they also show the distribution of the data. Now, another thing that is very nice is that you can add in some flair to it. So for example, we can combine this idea of a box plot with that of the violin plot. So we can say box is equal to true, and we run this, and you see here now it actually creates this nice violin plot, as well as inside it has the same box plot, where actually whenever you run inside there, it actually has those extra mean, median, quartile ranges as well, and it gives you a little bit more information. Now, one thing that we don't see here, like we had up here, Okay, I liked having this rug plot, but another thing that we can do is adding in, I usually call them a swarm plot, but we can actually just say points is equal to all here. And then next to it, it'll show you all the actual individual observations next to it. So then you can actually see them as well as deal with them. We can also maybe just turn off the box to see what it winds up looking like as well. And you can see that it keeps it off to the side. I personally like to have that box in there so that we get this extra bit of visualization in there, and it makes it very dense for us to look at. And again, if you want more on this, we can talk about statistics all day long, but right now we're going to focus on just the visualizations. So now let's actually look at something like this. This whole, we have all these dots and whatnot. So what let's actually go on and do, and let me reset this. Let's create a strip plot. And we want this to be tips. We want X to be our total bill. We want Y is equal to our time. And I'm going to leave this one blank, but let's do color. I want this by smoker. And I think that'll be fine for now. So here you see that we have lunch and we have dinner. We have all of the data actually plotted out here. This does look nice, but we can also change, for example, orientation. It actually will take a V for a vertical. And so notice here, this looks terrible. Okay, everything's lined up. So, but the standard is using something like horizontal here, and it actually gives them a jitter. Okay, it actually puts in a little bit of error, so they're not all lined up perfectly. And this is the standard in here, and so we can actually just delete that, but I wanted you to know that that is there. Particularly sometimes people like them when they're combining plots. All right, the next one is let's do some KDE plots or density plots or contour plots. So let's go back to the iris data set. And we'll do something like px dot density contour. A lot of times people just call these KDE joint plots. So this is on iris. Here, X is going to be our sepal width, sepal width. Y is going to be our sepal length. And you know what? We'll leave that there. So here you see that we have our contours, and we actually get a nice interactive preference. And again, we can do all kinds of interesting stuff with this. Again, just thinking about this as, again, like you were looking at a map or something like that, we can see the densities of, there's a lot of observations here, a lot of observations over here, and a lot of observations here as well as here. So you can use this to do all kinds of variations. And again, I would suggest double checking the Seaborn library as well to do stuff with this if you want more features. Now, one thing that we didn't do here is we didn't add in some margins, and we didn't add in some color. So let's change this up and add in color for the species. And let's run this. And so now you see here, we get this fantastic image where we have all of our Setosa virginica and versicolor in there, so we can see actually what's going on with each of those layers. And so you can see that actually those contours, actually, there's not a lot of difference in some ways between versicolor and virginica, except we also have some of these outliers for virginica. Another thing that we can add then is the margins. So we can do marginal X, and let's say we want a rug plot. Again, usually for rug plots, I usually do put them on the X-axis. They have a tendency to have this nice lining up for them. And then we can also do something on the marginal Y, and we can say we want a histogram. Can run that, and we can build on top of these. And this is you can do this on almost any of the other data sets and figures that we've done before. Okay, you can make them as dense as you want, but just remember that your user or your reader, there's user experience that is very important here. Okay, I would probably never put this much on plot, maybe no more than this on a plot, because people can get overwhelmed with the data and it can detract from the story you're wanting to tell. But again, this is nice, especially like if I'm getting ready to write a paper, I'm writing a report, I will put up something like this for myself so that I can have all kinds of discussion at my fingertips when I'm writing up the report. So the next one is okay, so here we actually did just a density contour, but I find this sometimes, again, having these lines here is sometimes very, very hard to look at and hard to kind of accept. So I'm just going to copy this whole thing and I'm going to put it down here. And instead of contour, here we're going to change this to heat map. Oops. And what didn't it like? Color. Oh yeah, because color here actually doesn't. We want the heat map. So it actually will choose the colors for us. Now this is actually extremely nice because it kind of bends everything up a little bit. It's very similar to using like a hex plot, but this is a heat map. So then you see where everything is kind of clustered together and it's very pretty. So you have these high cluster counts here, and then notice here as you go out, there's no counts out here. The count is 0. And as you get up to this yellow is the high count of 19, a moderate count of 12, lower counts of 3. So again, it's very nice to be able to see that as well. Now let's continue on with maybe some of the heat map images. You know what? No, I don't really. I think this is the only heat map I really want to show you guys. We can maybe do one more. Do I want to? No, I think we're going to move on from this. I don't want to waste too much more time on it because I want to get to something fun. Okay, so we're going to do maps. And I'm hoping that I actually have if I don't, let me double check. I think we're going to be okay. Because some of these sometimes we have to have a different API, but I think the examples that I pulled up today don't have that. So let's look at the car share database or data set. And so we'll actually take a look at the car share because it's a little bit newer type data set here, but it actually has this, it has a centroid. So this is actually mapping data. Okay, so it has this longitude and latitude. Now the longitude and latitude here are specifically centroids. So for example, if you have a circle, it's going to be putting it in the center of that particular circle. Here you're going to have car hours and then peak hour. So it's very nice. This will be able to give us a very nice plot when we actually start to look at it. So let's actually start with that. So we can do px.scatter. Oh, not sunburst, scatter. And here we do Mapbox. Okay, so what we're going to have is we're going to have dots on side of, or scatter plot on top of a map. So then we can do here, what do I want with this one? Car share. And here, instead of X's and Y's, we have our lat for our latitude. And we use this centroid latitude. And then we have our longitude here. And this is going to be our centroid longitude. Color here we'll put as, we want our peak hour. The size of each of these dots are going to be our car hours. Oh, and it's hours, and then let me put this on a new line. And then here, let's actually give it a max size here. Size max of 15, because again, some of these are going to be really big. We need to set a zoom to equal, let's do 10, I think. Let me see what the standard is for the zoom really quickly. Zoom is going to be between 0 and 20. Default is 8. So I want it kind of set basically at 50% zoom on the map. I don't want it all the way up in your face, and I don't want it to be looking at the world view. So I'm going to put it at about 50%. And And then let's also do map box style. Style here is going to be a Carto position, and we'll mess with the color scheme here in a second. What didn't it like? Oh, because it actually wants. Does it actually? Oh, maybe it's gonna have to. I'm gonna actually have to put that in. Color. Let me. Now I'm confused as to why it wants that. Let me double check really quickly. I want to read the. It's because I'm an idiot. It's because I misspelled the variable. It's peak hour, not peak hours. And hopefully it worked. Or is it just going to be white because I don't have the color palette picked? So let's do color, continuous scale, px dot colors dot cyclical dot, and we want this from hot to cold, so ice fire. All right, what didn't you like this time? Oh, whoops. It's because I can't spell. Again, it is a data science course. It is not an English course. So let's see if this will run. Well, it's there, but it's not there. Let me do something like matplotlib inline, and what if I show this? It should actually show us a nice see if that'll work. All right, let me double check something again. I think it has to do with using Jupyter Notebook. All right, so let me share with you guys what exactly happened. So the one thing I need to do is run this Mapbox. It's a website that actually uses these maps here. And I actually have a token. I forgot to actually bring in my API key. And so this is my API key. And what you guys can do is go to, let me actually set, you can go to, let me actually just open it up for you guys. And I need to file, open an incognito window so you guys don't see what I want there. You can go to mapbox.com and then you can sign in. Okay, and sign in here and it will give you, there is a paid subscription that they have, but you can also get a free API key. And so, but I didn't, again, I don't want to show you my API key because I use it often enough. And I created just a variable up top, but what you normally would do is do something like, you would save it in a file. For example, if you're putting this on a website or something, the code would look a little bit different. Let me actually show you an example here, and it would be something like this whole thing. And you would use, instead of this, you would do something like open a dot Mapbox token, and then dot read on there. This is the code that you would, can I zoom in on that a little bit so you guys can see it? This is the code here that you would use if you had this set up for something that you wanted a hidden file, and you wanted to be able to use it that way. But the thing that we're actually most important is that our plot is actually working now, and so that is with again, this is the Mapbox API. And so now you can actually see here that we have our interactive graphics. And let me zoom out again. I was just going to keep getting that big. Should be able to scroll over. There we go. So you can see here that we have our peak hours starting from 0 all the way up to I don't know what our peak hours is, probably around 30. And then you have all of our plots inside of here as well. And so again, we can select them. We can actually zoom in on an area, do a selection box maybe if you want to see a specific piece. And again, this is by car pickups, that type of stuff. Now, another common thing that we can create is, oh, let me find something real quick. My computer is starting to fuss with me a little bit. Didn't like that. Okay, so the next thing that we can actually go through and do is do a Chloropleth map. And so let's grab something like, let's grab some JSON data. So let's do some election data. And so we can actually take a look at the data. And you can see here that it has specific districts. It has some kind of code. It has the people, how they, I don't know, it's Bergenson and Jolie, I believe. And this is for, I don't know what country this is for. What country would this be for? Canada, I believe. Yeah, Canada. For their election. And again, here it says, for example, from the district, it has whether they are a winner, result was plurality or majority, and then it also has some sort of district ID. So now this is just one part of the data set, okay? This is the election results. Now we also need geospatial data. So we'll call this GeoJSON, and it's px.data.election, and then GeoJSON. And so this is actually gives us the Chloropleth data. So if I open this up to GeoJSON and I actually show this to you, it's going to look awful. Okay, this is actually a JSON type file. A lot of APIs come in this type of format, so I would expect you guys to kind of start to get used to and accustomed to seeing this type of data. So for example, this is the geometry, it has the coordinates, and what this does is this maps out like district lines. Okay, so you will see this a lot with any type of election data. A lot of contagion data does this. A lot of census data will also have these types of JSON geospatial data. And again, if anyone's interested in doing GIS work, that type of stuff, this is the same type of data. So the way that we actually plot these is px dot, and here we're doing a Chloropleth, and we also want to use Mapbox on here, and we are going to use our election data, and then our GeoJSON data is just GeoJSON, and then we want our color here is going to be Pergeron. Locations is going to be by the district. And then feature key here is going to be properties.district. Okay, and then we have our center here. We're actually going to be using, and I have this up in a note. So we have latitude here. We want 45, 55, 17. And then we have longitude here of negative 73.7.073. Did I do that right? Oops, I have too many decimals in there. And that is as a dictionary. And then we have our Mapbox style. And we're going to do the same style as that Carto positioner or positron. And then we'll do our zoom. Again, I'm just going to do it to 10 or 50%. You can think about it as 50%. Now, why? Why didn't you like that again? Run again. Oh, not DF. Election. There it is. So notice here, now this is exactly what that geo JSON is doing. So each of these election lines, you can see here that if I zoom in a little bit, you can see even there's, if I zoom in, there's like these little there to there, there to there, there to there, there to there, there to there. All of these little lines that it adds in are the geospatial coordinates that it's going in to make this Chloropleth map. So then again, you can see here that you can have all kinds of data deep in there. You can add in extra hover bars and texts as well. And let's do maybe 2 more maps, and then we'll call it a day today. So let's go back, and I think I still have the Gapminder data still in. Yeah, I still have the Gapminder data in, and so let's do a scatter plot on a geosphere, and let's do Gapminder. We have our locations. Now the locations in here, it actually will take in an ISO alpha, which is great because a lot of data does already have ISO alphas built into it. Color we'll do by continent. Hover name here will be country. And then we'll do size is equal to our population. And then we'll do an animation frame. We'll do this by year. And then projection here is natural Earth, and we'll play with that here in just a second. There you go. Location, why? Oh, locations, sorry. Locations. And then what else did I do wrong? Oh, whoops, I put the S in there. Okay, so the beauty of this, all right, we can grab, we can turn, okay? And then also if we, let me double click and reset this, we hit play, we can watch our populations grow over time. Okay, and again, so then you can have this nice interaction that's going on. Now we can also change up the type of projection that we're doing. So the projection is the style of the map, for example. So let me just run this with the normal. Notice now it's just this nice square box. But the one that I always find is really impressive is, let me pull it up so I can actually see it here. I want to move this down. What is the one I wanted to show you guys? So I'm looking through the documentation here, and let's see about projection. Okay, so look at all of the projections that we have here. All of these projections. Okay, and I think that the one that I liked was the stereographic. Looked very cool. So let's change that and do projection is stereographic. Yeah, and so this actually looks like an actual ball, but it's an inverted sphere. Okay, and so it has this very weird look and feel to it that is very, it can be very pleasing to the user because it actually makes them feel like, again, so here, like I can make it so that it looks like we're looking down at the Earth, and then now if we run the simulation again, it will move it again. I want to move it over. I want to move it. This is what I want. There. Stay there. No, stay there. There. There we go. So now you can see, for example, you can see Africa, you can see parts of Asia, as well as North America in here, and you can see it growing as well. And let's do one more of this nature, and let's do a Chloropleth map. So then we can see similar things like we'll do basically the same data set, but we'll, instead of having these bubbles, we'll have it changed by life expectancy based on the Chloropleth. So px dot, and here we have this Chloropleth, and I don't want the box. I want just the Chloropleth, and we want the Gapminder data. Locations is going to be the ISO alpha. The color here, we'll do life expectancy. We'll do hover name. Here is going to be country. And we'll do the animation frame is going to be year. And we need to actually create a range in this one for our color scheme because we're going to be doing it's kind of like a hot blue, and so let's do something like what was the life expectancy max min? Let me look real quick. So let's do Gapminder, and we want what? Life expectancy dot max. Let's print this out, and let's print Gapminder life expectancy dot min. Okay, so from 82 to 23. So let's do 80 to 20. So it has a little bit of a cutoff there. So range color here we'll do from 20 to 80. So then now we can see that we have this nice map here. And again, we can change the how it looks, but if we hit play here, you can see about the life expectancy changing over time as things start to get lighter. Okay, the life expectancy goes up, and that's why worldwide life expectancy has increased, and that's why the whole entire map has started to get lighter over time. Thank you guys for watching. If you guys like this, please comment, subscribe, and click that like button, and I will see you guys next time. Bye-bye.